In this video, we are going to go over we're going to apply the modified Gram-Schmidt orthogonalization to find the full QR factorization of the matrix 4, 8, 1, 0, 2, -2, 3, 6, 7. Before I begin that, I should highly note that I'm first going to do the regular QR factorization, so not the full one first. You'll see why though once I actually do indeed do it. But for this, we have a matrix, which I'm just going to call A. All right. So in order for us to build a QR factorization, the non-full method first, the value of y sub 1 just takes on the first column of our matrix A, which is 4, 0, 3. The value of from the matrix R that we want to create, the value R sub 1, 1. This takes the norm of y sub 1. So taking the norm of this, we would square each value, add them up, and then take the square root. So 4 squared plus 0 squared plus 3 squared. And we would take the square root of that. Turns out you get an answer of 5. And the value of q sub 1, 1 is going to be equal to y sub 1 divided by the norm of y sub 1, which we just found. If we do that out, we would obtain this vector, 4/5, 0/5, which is just 0, and then 3/5. Then for y sub 2, this one now is a bit different. We do a sub 2 now minus q sub 1 times q sub 1 transpose times a sub 2. So nice, big, long equation. Written out with the vectors, this is going to be the second column, so 8, 2, 6, minus q sub 1, which I actually called q sub 1, 1 over here. This, I should probably get rid of that second one to not make confusion. This will be minus then 4/5, 0, and 3/5. And that's a very bad 3 in my end. Oh goodness. Okay. Moving on then. Times the transpose. So 4/5, 0, and 3/5 times the second column of A again. So 8, 2, 6. We can slightly simplify this multiplication. So let me just write this out very quickly. This will be 8, 2, 6 minus 4/5, 0, and 3/5. Q1 transposed, Q sub 1 transposed times A sub 2. When we multiply these two vectors, we obtain the number 10. So now when we do 8 minus 4/5 times 10, we would obtain the value of 0. 2 minus 0 times 10 is just 2, and 6 times 3/5 times 10. So 6 minus 3/5 times 10, we would get another value of 0. And that's our value of y sub 2 now. So we could build q sub 2 to be y sub 2 divided by the norm of y sub 2. Since we had a value of only 2 and a bunch of zeros, the norm then of y sub 2, let me do that right here actually. Norm of y sub 2, in this case, would just be the square root of 0 squared plus 2 squared plus 0 squared. You do that out, you would get an answer of just 2. So we're just dividing 0 by 2, 2 by 2, and 0 by 2 to get a vector of 0, 1, 0. This norm that we just calculated, this is actually the value of r sub 2, 2. To get the value of r sub 1, 2, we would take the transpose of q sub 1 times a sub 2, which we did over here to get a value of 10. Okay, so we got those parts in. We need to do this once more. Y sub 3 is going to take the value of a sub 3 minus q sub 1 times q sub 1 transpose times a sub 3 minus q sub 2 times q sub 2 transposed times a sub 3. So we have a much bigger equation here. Let me try to write that all very quickly. So a sub 3, the third column in A is 1, -2, and 7. This will be minus 4/5, 0, and 3/5 from our earlier calculation times the transpose. So 4/5, 0, 3/5 times 1, -2, 7 minus, and let me not make a mistake. So minus q sub 2, so 0, 1, 0 times its transpose, 0, 1, 0. I did that way too close. 0, 1, 0 times a sub 3. When we do that out, that was 1, -2, and 7. We could slightly rewrite this to make life easier for ourselves. We would have 1, -2, and 7 minus 4/5, 0, and 3/5. When we do q sub 1 transpose times a sub 3, we would just want to multiply those two, and we would obtain ourselves an answer of 5 minus, this will now be 0, 1, 0 times q sub 2 transpose times a sub 3. We do that out, we'd only get a value of -2 because we only take the middle value of the vector. So now we have this equation, which we could solve. So 1 minus 4/5 times 5 minus 0 times -2. That will give us a value of -3. -2 minus 0 times 5 minus 1 times -2 will give us a value of 0. And then 7 minus 3/5 times 5 minus 0 times -2 is going to give us a value of 4. So that's our value of y sub 3 now. when we could take the vector norm of y sub 3, which is actually going to be our value in our matrix R, the value of R sub 3, 3. This is going to be equal to, and again, we will just square each of these, add them up, and take the square root. So the square root of -3 squared plus 0 squared plus 4 squared. Do that up, you get an answer of 5. Again, let me just give myself a slight bit more room to finish writing this. Okay. Then from that, we could then find the value of q sub 3, 3, q sub 3, excuse me. Q sub 3 to be y sub 3 divided by the norm of y sub 3. So this would mean we are just dividing each of these values by 5. So -3/5, 0, and 4/5. And so we just need the value of R sub 1, 3. R sub 1, 3 is equal to the Q sub 1 transpose times A sub 3, which was 5. The value of R sub 2, 3, which is the last one that we don't know about, this was Q sub 2 transpose times A sub 3, which that gave us a value of -2. Okay, so now we can write out a full QR factorization. So let me just rewrite what A was. This is 4, 8, 1, 0, 2, -2, and then 3, 6, and 7. So if we write that out now using the QR factorization, our matrix Q, so Q sub 1 was, where did I write it? Right here. This would be 4/5, 0, and 3/5. Q sub 2 was 0, 1, 0. And Q sub 3 is -3/5, 0, and 4/5. The matrix R. We will be taking these various values that we found. So we have 5, 10, and 5. Then we have a 0 here, and then 2, -2, and 2 more zeros, and where did I write it? I wrote it right here. R sub 3, 3 was 5. Okay, so in conclusion, based upon the QR factorization, this matrix here is Q, and this one is R. So now, from when it comes to the full QR factorization, all the math that we just did above, almost all of it stays the same. The only difference is the value of y sub 3. That's the only thing that changes. And when I say the value changes, the only thing that changes on it is the calculation. So that was A sub 3 minus Q sub 1 times Q sub 1 transpose times A sub 3 minus Q sub 2 times Q sub 2 transpose times A sub 3 minus Q sub 1 times Q sub 1 transpose times A sub 3. Written out as an equation, this will give us the values here of 1, -2, 7, minus 4/5, 0, 3/5 times the value of 5, which we found from above actually up here, minus 0, 1, 0. The value of Q sub 2 transpose would be 0, 1, 0. And then we would have inside of the Q sub 1 times Q sub 1 transpose times A sub 3. That would be whatever we find from this first portion. So in that particular case, how do I want to go about writing that one back up? I could just write in its parts again. This would be times A sub 3. So 1, negative 2, 7 minus, this would be 4/5, 0, 3/5 times from what we got before, again, of 5. Okay. So we can, let's see. We can very slightly rework this. Inside of this parenthesis, let me just write what that becomes. Inside of this parenthesis, we have 1 minus 4/5 times 5. So that would give us a value of, let me do that math that way here. 1 minus 4/5 times 5. This would give us a value of negative 3. Negative 2 minus 0 times 5. That gives us a value of negative 2. And then 7 minus 3/5 times 5. This would give us a value of 4. So we could slightly rewrite that equation as 1, negative 2, 7 minus 4/5, 0, 3/5 times 5 minus 0, 1, 0 times 0, 1, 0 in transpose times now this vector negative 3, negative 2, and 4. And then very quickly, we could just do one last simplification for these two being multiplied together to make it look a little bit nicer. This would be 1, negative 2, 7 minus, this was again 4/5, 0, 3/5 times 5 minus 0, 1, 0. And then when we multiply these two, we would just obtain the number of negative 2. So now when we go to solve this, we would obtain 1 minus 4/5 times 5 minus 0 times negative 2. That will give us a value of negative 3. Negative 2 minus 0 times 5 minus 1 times negative 2. That will give us 0. Then 7 minus 3/5 times 5 minus 0 times negative 2. That would give us a value of 4, which, as you can see, we get the vector negative 3, 0, 4. And that matches the exact vector that we had up here for y sub 3, which was right here. So that's the only difference is the calculation, but all the other work is the same. And we would obtain this exact same answer if I do out the work. We would obtain the exact same answer, which for some reason I wish I could highlight, but it's not letting me highlight right now. We would obtain this exact answer right here of these two vectors being multiplied together. Let me know if you have any questions or concerns. Thank you.